Okay, so before starting off my session, I would like to know, like from all the people, does anyone know anything about event-driven architecture? I mean, it would be great if anyone knows about it. We can have like a good discussion in this session. Does anyone know about it?
No, कौन सा
yes,
कौन बता
Bobby.
रहा है?
Okay. Anyone else?
Yes, Bhavya, I am also slightly aware with the subject.
Okay, I think let's move forward and let's start it, and we'll have a discussion going forward, right? Okay. Uh, so first of all, let's talk about knowledge certificates. So I request everyone to join the session 5 minutes prior to the session, and make sure to submit a constructive feedback for all the sessions, as it is very helpful for the presenter. And then keep your mobile phones in silent mode, and feel free to move out session in case you need urgent call. And I would request everyone to avoid unwanted chat during the session. Okay, now let's talk about the agenda. So we'll be first of all talking. I'll be giving you an introduction. Then we'll move forward with key aspects, or we can call it as advantages of event-driven architecture. Then we'll talk about disadvantages of event-driven architecture. We'll then move forward with journaling in event-driven system. We'll understand what journaling is, how do we use it. Then we'll talk about the key aspects of journaling in event-driven systems, and I'll then give you a small demo to you guys. Okay. So first of all, let's start with the introduction. So event-driven architecture is defined as a software design pattern in which decoupled applications can asynchronously publish and subscribe to events via an event broker. So if you focus on this line, it has mentioned decoupled applications. First of all, we are talking about a microservices architecture here, right? So when there is a microservices architecture, we have a distributed system where we want all the microservices to communicate with each other, right? So there are different ways of communicating with the within microservices. One of the way could be making an HTTP API call to the other microservice, and then we make a request to that service, and then we'll wait for the response for that API, and then our request completes. This is one way. Another way of communicating between microservices is events, which we are talking about here, right? So the system here is decoupled. There is no coupling between them. They are both independent services working independently, right? And they are communicating asynchronously. In the coming slides, we'll also see how we are communicating asynchronously, and we'll also do a deep dive into what events are, what is event broker, how we are doing an asynchronous programming, what are decoupled applications, right? So then we have event-driven architecture is a way of building enterprise IT system that lets information flow between applications, microservices, and connected devices in a real-time manner as events occur through the business. So you see, we are trying to flow the information between microservices or maybe your connected devices. We are talking about microservices here, and that happens in a real time whenever some kind of events occur. In the coming slides, I'll talk about how events occur in a system and what actually they are. And by introducing a middleman known as an event broker. So when microservices are communicating with each other, there is a middleman known as an event broker. So event-driven architecture enables what's called loose coupling of applications, meaning applications and devices don't need to know where they're sending information or where the information they're consuming coming from. So that's a very important point, that the different microservices don't need to know like what information they are sending to and from where they are consuming. They just know about the event broker, which is an event bus. They have just subscribed to that, and they are just consuming those events and processing over it, and they don't know where that event came from. uh, I'm sure that in the coming slides you will better understand this, and these maybe there are a lot of terms which many of you might be hearing for the first time, but in the coming slides you'll understand it more, right? Let's talk about the key aspects of the advantages of event-driven architecture. Now let's break down everything and understand each part separately. So first of all, event. Many of you might not even know about what an event is, right? So events are occurrences or happenings within a system that are of interest. These can include user interactions, changes in data, system notifications, or any other significant activity. So event is just something happening inside a system or a service. So, and it contains an information, right? So for example, when we are making an API request, there's an information going on. Like we are making a request that to other microservice, and then we get some kind of information back. So events is kind of an information which is flowing through the system, but that is asynchronous. So event can be anything. I can give you an example of maybe, for example, let's say there's an e-commerce platform and someone is trying to purchase something, and as soon as a user uh, tries to place an order, that placing an order is an event in itself, right? So it's an information, right? Then moving forward, event sources or producers. So these are the components or entities that generate and emit events, and these could be interfaces, sensor, database, or external system. So producers are maybe we can call them as the services who are actually uh, producing or publishing an event. For example, let's say uh, let's take an example of an e-commerce platform, and we have an order service, and then we have a delivery service. For example, you're generating an order, you want that order to be delivered, right? So we have a microservice architecture, and we have broken down that into two microservices. There could be many more microservices as well, but as of now, let's take an example that there are two microservices, order and a delivery system, right? So here, as soon as an order is generated in our order service, that will publish an event, and the delivery service wants to know that there is an order generated, right? Because as soon as an order is generated, the delivery service is responsible for delivering that order to the customer. So here the order services can be called as a producer because that is publishing an event, and the delivery service is the consumer here. So we have consumer. These are the components of services that react to specific events. In this case, delivery is the service which is consuming that order event, and that is reacting to that. For example, that is processing, doing a processing, maybe calculating some delivery estimates, and notifying the customer that we have received your order and your order will be delivered within 7 days or 10 days, depending upon the location. So so here delivery service reacted to that specific order event. So that is a consumer. Then we have an event bus. As I've explained earlier also, we need a mechanism or a communication medium. So here we have talked about that there are events flowing through the system, but those events need a medium to flow, right? And that flow is being done through this event bus. So events will travel through between like microservices via event bus or a broker. So an event bus or a broker is a communication channel through which events are transmitted from event sources to event handlers. It acts as an intermediary that facilitates the decoupling of event producers and consumers. So I've already said that, I mean, there's order service, delivery service, and there would be a medium of like there's a event broker on which the events will flow. And this is how like everything works in an event kind of a system. Let's see more key aspects. So one is loose coupling. This can also be considered as a benefit. So one of the key benefit of event-driven architecture is loose coupling between components. Event sources and event handlers are independent, and changes in one do not directly impact the other. This makes the more system and easier to maintain. Let me explain. So since we have introduced, I mean, let's say there are no events in the system. We are not doing an event communication. We are just making an HTTP API call, right? So in that case, we are making services dependent, right? Because that is a synchronous call. So let's say we generated an order, the order service received that order, and that wants to uh, inform delivery service that I have got an order. So what if there was an HTTP API call? Then the order service would have to make an HTTP call to the delivery service, and the order service would have to then wait uh, to get a confirmation from delivery service in the form of an HTTP API response that yeah, I have received that order, and that is done. So this is making the system more coupled. They are becoming dependent on each other. Since we are trying to make an asynchronous system via events, it helps us. It's a benefit that both the services will work independently. So the order service will receive an order, and that's all. Like the order service will receive an API request, and that request will get completed as soon as the order is generated. The order service will not wait for a delivery service to perform its processing. Both are working independently. So that is why, like, via events we are having a loose coupling here. Then asynchronous programming, events are processed asynchronously, that I've already talked about, meaning that the system doesn't wait for an immediate response to an event. This asynchronous nature enhances system responsiveness and scalability. See, we have more benefits here. Like, for example, in the above point, we have said that we have seen that the systems become more flexible and easier to maintain. So since services are independent of each other, we can scale them easily, maintain them easily, and they become responsive. So these are also the benefits. Then the last point, scalability and flexibility. So event-driven architecture is well suited for building scalable and flexible systems. So we have a flexibility, maybe in terms of maybe memory or in terms of request, we can scale out or scale in both the service independently, right? So new functionalities can be added by introducing new event handlers without modifying existing components. So for example, now we have the order service is responsible for maybe performing some more kind of action. Then we can introduce another event handler, which will event again some more events, and the delivery service will handle those events again. So it helps us to maintain these things easily, and we can easily introduce new events independent of each other in both the microservices. Till now, like, does anyone have any question, or anyone would like to uh, have a discussion on how things are, what are the benefits, what are the maybe even the drawbacks? Does anyone have any question?
Hi, Bobby. We got the benefits of the event-driven architecture, but what can be the like cons of this architecture?
Yeah, we'll be discussing about the disadvantages in the coming slides. But yeah, you are asking this because every system has its own benefits and every system has its own disadvantages as well. There can never be a system which is like 100% foolproof and which works for every scenario, right? So yeah, we'll discuss about those. If anyone does not have any question related to these aspects or advantages.
Bhavya, uh,
Mhm.
you talk about the event bus. So, do you have any example of that? I mean, like we have MSMQs, like what kind of event bus we are using over here? Like, is it a third party thing or we code it like that? It's a event
Yeah,
bus.
yeah, we actually do have a lot of event bus example. For example, one of is Amazon Kinesis, that is providing a platform or a medium for us. We do have many messaging platforms like RabbitMQ. Then we have Kafka.
Yeah, right,
These are
right.
all the these are all the services which helps us to publish and consume events and provide those
Exactly.
event bus as well, right?
Right,
So
right.
actually, it is very much not feasible for an engineer itself to develop the entire event bus, then developing everything from
Exactly.
scratch. So that is why we
Right.
do have like many of the third parties services available
Even
to us.
mostly it's used RabbitMQ or Kafka.
Yeah,
Most
RabbitMQ
of the
is
people.
widely
Yeah.
used. Yeah, right. For example, the project I'm working on that uses Amazon Kinesis. I've seen many projects working on RabbitMQ as well, Kafka as well.
Yeah.
So
Yeah.
yeah, those are all the
It's a bit easy, just get the
yeah.
nuggets like mass transit or something like that. You will get the
Yeah,
RabbitMQ and then you can go ahead with that.
right. We do get a lot of thing out of the box. We don't have to like go deep down
Right.
into everything. Yeah.
Exactly.
So that
Exactly.
yeah,
Yeah. Thanks.
yeah, sure. Okay, let's move forward then. Uh, so this is an example of events, how events flow. I'm actually showing this because many of you might not be able to imagine it, how events are working, because this might be something new thing for many of you. So I gave you an example for an order and a delivery service. Let's say there are three microservices. So What is the benefit here also? You can see that here we have an order service, which is one microservice, and then we have inventory and the delivery service. So order service received an order. As soon as it's received an order, it emits an order event to the message broker, right? So an order event is flowing through this message broker, and the inventory service and the delivery service both have subscribed to this event, and they consume both, like they consume the same event at the same time because they are working independently, right? Because here you see inventory service also need to know about order data, right? Because they are managing inventory, how many products do we have, and as soon as an order event is received, they might be processing, like they might be reducing the number of products they have in their inventory, right? So the processing in this inventory service will be independent, and the processing in the delivery service will also be an independent thing. So this is how the events flow into the system. Let's move forward and see how the event bus looks like. This is an order service, inventory, delivery service. So you see there could be many more microservices, and all those microservices they just listen to this event bus. They are not connecting directly. In the previous slide, you might be getting confused that they are connected directly, or but you see here, this is how you can imagine about an event driven system looks like. So every system, as soon as like every service is introduced, that just tries to listen on this event bus, and as soon as like an order service emits an event to this event bus, all the services who are listening to this event bus can get to know that there is an order event flowing through the system, and then we can just consume that and do the process accordingly, right? So this is how events flow through the system. Okay, moving forward, let's now talk about disadvantages. We have already talked about the key aspects and all the advantages given by the event-driven architecture. Let's see the disadvantages as well. So the first point is complexity. Implementing and managing an event-driven system can be more complex than a traditional or synchronous system. So we have a monolith system, and then we have a or a microservice architecture, right? So as soon as we have introduced this microservice architecture uh, and have introduced this event-driven system, it becomes more complex for us to manage things. So it depends how much big system you have, and depending on that big system, then you decide like, do you need a monolith or a microservices, or do you need to implement this event-driven system? Because we need to manage these events, publishing, consuming, what the event might look like. So there's a complexity introduced to it. Then we have debugging and tracing. So debugging in an event-driven system can be challenging, as the flow of events and interaction between components may not be immediately apparent. So you see, whenever there is a bug, and you have, let's say, 10 microservices, and the data is flowing through, let's say an example, uh, as soon as an order is generated, there were maybe 4 to 5 microservices who consumed that event and did the processing. As soon as we see a bug in any of the microservices, it becomes a very big challenge for an engineer to find out the issue. Was the issue in the event itself? Was the issue in the current microservice itself? Do we need to go back to the previous microservice which published that event? So it becomes a bit of a challenge to an engineer. And the tracing of sequence of events for troubleshooting can be complex. We also might need to understand the sequence of events occurred. For example, an order was received, then that order was later updated, then it was again updated. So tracing that is also a bit of hassle for an engineer. Then we have consistency and ordering. So maintaining the order and consistency of events can be challenging. So there could be many systems where the order of events could be very crucial. So in those systems, the engineers need to make sure that the order of events is correct, and that is also another challenge in itself. In some cases, ensuring the events are produced in correct order might require additional mechanisms impacting performance. So there could be some cases where the correct order to maintain the correct order, you might require some services or mechanisms, and which can impact the performance. So this is also another disadvantage. Then we have event overhead. So the use of events introduce some overhead, especially in terms of event propagation and handling. In certain scenarios, this overhead can affect the overall system performance. So since now we are dependent on events for the communication, uh, it can also become an overhead. Just say, for example, we received an order service emitted that event, but that event maybe there was an issue with some event bus, or there was some kind of delay for that event to reach to delivery service. Delivery service could not get the event on time. That may create some delays in the system, and that is how it can affect an overall system performance. So that is another thing which we need to handle. The last point, I think we have more. We have event loss. So if not handled properly, events may be lost, leading to potential data inconsistencies. We can take the same example. We received an order, but due to an event loss, we were not able to deliver that order. So there is no sense of having an order if we cannot deliver that product to the end customer, right? So we need to maintain that each event is crucial to us, and we need to make sure that there is no event loss, right? Uh, okay, that was all about the disadvantages in event-driven system. Uh, I hope like everybody is able to understand what are events, because this is a really very important architecture, and I think almost everywhere we are using this nowadays, because the systems have become so big that like everyone is moving to this event-driven system. So I hope everyone is like able to understand. Does anyone have any question till this point? I consider the silence as
Hi, Pavya.
hi, Moika.
I was just wondering that how reliable is this? Because as you said that there is no the services don't wait for any response. So
Mhm,
when like we have our order service has published the order, and anyhow the delivery service has failed and it cannot
mhm,
consume. So that
mhm,
how would we know that it is not able to consume? As in the projects we have so many services. So how does this
mhm.
thing work?
Yeah, so that is what it's you see is on the screen, journaling in event-driven system. I think your question will be answered via this because so I mean, one thing we need to make sure here is, first of all, the engineers always need to make sure that all the services are working properly, right? We do have monitors in place that every service is working fine, the order service and delivery service, even if the delivery service fails, right? So we have mechanisms of although the third-party services, for example, Amazon Kinesis, RabbitMQ, Kafka, these services provide automatic like a queuing mechanism where as soon as the delivery service comes up, that service starts consuming those previous events and those gets processed. Even if the event bus is not able to maintain that queue, we have a mechanism of replaying events. For example, order service received an event, but there was some issue with delivery system, so we were not able to deliver that. And later we get to know via some monitors or something that the delivery service is not working. But we have already received the order. We're not going to receive that again. So what we have some kind of mechanism here of replay. We can replay those events, and those events will again get published to the event bus, and then the delivery service will be able to consume that and then start working. So we have those fault tolerant system also. In the coming slide, we do have like a diagram also where I'll show how we replay these events, how do we persist them, what does happen in case of failures. So yeah,
Okay, okay.
that's the
So
major.
we'll be knowing this by logs only that yes, this has failed.
Yeah, if you're asking specifically about how do we know how whether a services has failed or not, we have many monitors in place. For example, there's a health check. There is a periodic process, which what happens is that periodic process keeps on hitting the database. Like it just runs a simple query: select star from this table, select star from this table. So every few seconds that tries to hit that table. So this is called a health check. In many of the projects, there is this health check in every microservices. And as soon as this health check is failed, for example, a microservice is not able to get the data from database, we just try to implement a simple query so that we get to know that is working fine. So let's say for every 10 seconds, delivery service will try to hit the delivery database, like delivery table. So it will do every 10 seconds. And as soon as it doesn't get, it is not able to hit that database, we get an alert. We do set up some monitors there, and we do get an alert that delivery service was not able to hit the database, so there's some issue. This is so this is called a health check, which we have in every microservice, via which we get to know. And we have some other mechanisms also. We have logs, we have alerts, we have monitors. So via these things, we get to know whether a service is working fine or not.
Okay, okay. Thank you.
Okay, you're welcome. Let's move forward with the journaling and event-driven system. This is, I think, I think there are many people who have already worked on this event-driven system. For example,
Yeah,
I think,
adding to that, in MSMQ you have dashboard as well from where you can check it.
yeah, we do get many dashboards, or I think everyone maintains these health checks or these monitors in place, because I think it is very crucial. We need to maintain our system 24/7, and we need to make that fault tolerant. So yeah. Okay, so many of you have already worked on. Some of you have already. I've heard the people saying RabbitMQ or Kafka, so I know that you have worked on it. I think, but you might not have heard about this journaling system, or I'm not sure. But this might be something new for many of the people, right? So let's understand what journaling actually is. So journaling in the context of event-driven system typically refers to the practice of recording or logging events for various purposes, such as auditing, troubleshooting, maintaining a reliable record of system activity. So journaling, from the name itself, we get to know that we are logging or storing events somewhere, recording or logging those events. So we need to keep a record of those events, that these events occurred, because in case of failures, we might need to take a look at those events, maybe for debugging purposes, or maybe replaying those events, so that when the other services comes up, we can replay and then get the processing complete, right? So we'll see how we do that. I also would like to demonstrate a demo, right? Uh, we have less time. Let's move forward. So the journaling mechanism is crucial for ensuring data integrity, traceability, and accountability in distributed and event-driven architectures. So we are doing this journaling mechanism for traceability. We need to trace events, how they were published, where they were consumed. So we try to store everything, right? Let's move forward. So let's talk about the key aspects of journaling in event-driven systems. So why do we do that? We are doing this for an historical records. So the event log serves as an historical record for all significant occurrences within the system. So we have a history of all the records. For example, let's say an order was generated 6 months back, right? And today we get to know that there was some payment issue with that order. Let's say a company, what it does is it tries to create that payment billing system in every 6 months. So every 6 months, all those orders are collected, and after 6 months, we got to know that there was some payment issue. So we need to know how was that order generated in order service, how was that published, where did it go, which microservices consumed that event, and what were kind of processing that microservices performed. So we are trying to maintain an historical records in our system for debugging purposes, or maybe to trace something, right? So event sourcing, instead of storing the current state of an event, so system maintains a sequence of events that led to the current state. Just an example, an order is generated. So we have persisted that an order is generated. So it's a create order event. Then if that order was updated, then we'll store that update order event. Then that was again updated. So we'll again store that update event. So for example, after 6 months, we'll get to know that this order was created on this date, and after 2 days, this was updated. Maybe the destination was updated, or some name was updated, and later on it was again updated. So we need to we maintain a sequence of events in our system, and we can maybe do that maybe via some logs or database tables. We'll see that in the coming slides. So we are maintaining the sequence of every event. So every microservices knows about everything. At the consumption side also, the microservices store as soon as it consumes the event, it stores that somewhere, maybe in a log or a database table, and it stores the sequence of events in itself also. So both the microservices know these are the events this order service published, and these are the events delivery service consumed. So we can compare which was the event missed, or there was something off, right? Then fault tolerance. Journaling enhances fault tolerance by providing a reliable source of truth about the system past. So we are journaling, we are making the system fault tolerant. We can replay those events. We can see the sequence of events. So we are So even if the system was down, this still has those events. So we can get recover through those. So that is how it is fault tolerant. As I've said, we can do an event replay. We can replay those create update events, and that will get consumed by the delivery service, and that will do the processing. Consistency and atomicity. Each event is treated as an atomic unit, and the log ensures that events are processed in the order they were generated. So with the sequence of events, like the journaling of events, we are storing those events, and every event is an atomic unit, like an independent event in itself. And the log ensures that the events are processed in the order they were generated. For example, there were 5 events. So we are journaling. We do some kind of timestamp. We store those timestamp. On the basis of timestamp, we can process those record in a specific order. So we have that benefit. Event metadata. So event metadata is as I've talked about, you can see such as timestamps, unique identifiers, or information about the source. So we can store timestamps about those events so that every microservices know when was that event published or when was that event consumed. So that's an event metadata. Yeah, I would like to show this data flow which I've created, and let's try to understand how these events stored in the system and how this is helpful. So let's consider this this is the data flow for our order service, right? So this is an entire order service. We have a database layer in itself here, and and we have Akka actors here. I don't know how many of you know about Akka, but I think most of you must be knowing about Akka actors. So let's say this is a request API, and this is an API request for an order, right? So what happens is we received a request from a user which is trying to purchase something from an e-commerce platform. So we got an order from this API. It's an API request. And since we are generating an order, like creating an order in the system, this will be an post endpoint, post order. What this API will do, it will do some kind of validation, some kind of processing. And when that is completed, it will persist that into the DB table. We can call this DB table as an order table. So we got the request, we persisted that and returned the response. So that's all. The user got to know that the order is created in the system. That's all, right? Now rest of the everything is asynchronous. Since API request is hit and the response is sent back, that's done. And this is why it's an asynchronous, because rest of the things are are going to process asynchronously. So what we have a mechanism of processing table, and for you all, these are all the tables. This journal is also a database table. This DB table is also a table. This processing table is also just a database table. So all these three are database tables. So we are using these tables for this event processing. Let's see how it happens. So as soon as the order is received in this database table, order table, we have a trigger on this table. And via this trigger, we'll insert the same record into a processing table. So now we have an order in processing table. And what is happening is there is an Akka actor. So what is Akka actor is doing is this actor is a scheduled actor, and this actor will keep on pulling the records from processing table. So the responsibility of this actor is to keep on pulling records from this, and it will keep on polling and see if there is a record. If there is a record, keep on polling maybe every 10 seconds, 30 seconds, and see if there is a record. As soon as the Akka actor get to know that there is a record in this processing table, it will try to process that record. And when it tries to process this record, this is the actor which will publish events. So you see, asynchronous programming is between microservices as well, but within a service also, this is a single service. We are making asynchronous processing. The API request and response is completely different, and this actor processing is completely different, which will publish events. And if this was not asynchronous, if this was everything synchronous, then API request would have to wait for DB table, then trigger processing table, then the actor. And when the events would have published, then the actor would have sent some kind of response to the API, and then the response would have sent to the user. And this would be like a very long process and a long waiting process for the user. That is why we have made this system asynchronous. So processing table has a record, DB table inserted this record, processing table, actor polled this record, actor successfully processed this record, published an event via order service, and stored that event in a journal table, right? So this journal table will have one record. And what one more thing this actor will do, this as soon as the actor will process the record successfully, this actor will delete the record from this processing table. You see, we receive the record in DB table. Then this table inserted in the processing table. This record was processed by actor. It got processed successfully. Actor deleted the record from this table, and the record was inserted into the journal table. So if we talk about the current state, we have a single record in DB table and one record in journal table. So you see one way of, okay, let me explain one more thing. Let's say this actor had some kind of error. It was not able to process, it was not able to publish that order. Although the user has created that order, but there was some error with the actor. What this actor will do, this actor will reinsert the record into the processing table. You see, this actor will reinsert the record in the processing table, and there will be an error field. Then we'll store the error in that error field table. And so you see, we need to make sure that if this DB table, this order table has 10 records, then we need to make sure that this journal table also has 10 records. Then we'll get to know that, yeah, we received 10 orders. It was processed successfully. That is why we have 10 records in journal table. As soon as there is a difference, there's 10 records in order table and there are only 5 records in journal table. We'll as soon as get to know that there was an issue with 5 orders, and those 5 orders must be stored in this processing table with some error. And maybe we can implement some kind of retry mechanism. There are other ways of handling that, but we'll still have records in this table, right? So we have 5 records here, 5 failed records here, and 5 successfully processed records here. So this is like a journaling system. And okay, understand one more thing. There is a post request to this API. The record will be created, and we'll also store that whether it was a post or a put. If it was a post, we'll record that exact field. Like this was an insert record. This will be inserted in the processing table, and the journal table will finally have a record with the operation insert. And as soon as, let's see, this order was updated, we'll see an update field. The same processing will happen. The record will get inserted into the processing table. Actor will process that record, will again insert in the journal table. So now in the journal table, we'll have 2 records. First record will be a create order. We'll have a field with a create field, and then we'll get another record. The order will be same, but the operation field will be update. So you see, we are journaling everything here. We have a create order, then an update order. So we are using this journal table. We can understand that how was the sequence of events occurred in the system, right? So this is how everything is happening in the system. I mean, I don't know, this might be a bit confusing for many of you. But this is how journaling works. So, okay, I have just 5 minutes. I would like to show you a small demo, how this journaling occurs in the system. Okay, let me open this. So I have this order service. Let me run this. So I'll run this. So when this is running, I'll show you some tables here. So we have this orders table, which I've shown this DB table. Then we have this order processing queue. This is the processing table. And then we have something called order journal table. This is the final table, right? So I'll try to hit a post endpoint. Let me open Postman. So this is a post endpoint to the local host we are doing. Let me send a request. Okay, so the request was successful. You see, we got the response. Now let's see how the orders of events occurred. Let's see in the orders table, select star from orders. You see, we have got one record with the order is this, the order number is this, then this is the merchant, this was the total amount of the order. So what I was showing in the table was we should have one record here. And if the record was successful, we should have one record in journal table. Let's see in the journal table, select star from orders journal. You see, we have one record in the orders journal table. And you can see here, the operation was insert. And as soon as we are hitting a put endpoint, the operation would be update. So this is how we are doing a journaling. And I also told you that this processing table, as soon as the record was successfully processed, the record gets deleted from this processing table via actor. So let me see. Let's see whether we have a record in this orders processing queue. You see, there are no records. So one thing to note here is that we need to make sure all the time that this order processing queue is always empty. This would ensure that all the orders got processed successfully, and we were successfully able to publish the events from this order service. It means that if there are 0 rows, which means that if there were 10 orders generated, then the 10 orders must have got published from this service. And then maybe we can debug further if there was some issue. We can then go to the delivery service and see whether those orders were consumed or not. This is how we do the debugging, right? Let me quickly show you what happens like if there's an error, right? Let me quickly truncate these tables. I can truncate table orders. I can truncate orders journal, right? Okay, let me go to the code. So this is the actor. This is the one which I'm talking about, which is doing a polling. So this is the orders journal actor, which extends the DB poll actor, which is doing the poll. Now we are processing the records, insert and the update records here. Let's say that it was not a success, and we throw in an arithmetic exception here, right? So this actor was not able to publish records. You see, I've written that this actor will be responsible for publishing using Kinesis records. Okay, now let's see what happens. I'll again try to hit the let me work on that. Let me try to hit the endpoint. Okay, this was completed. So let's see again. Let's select star from orders. So now we again have record. Let's select star from orders journal. You see there are no records in the order journal. So we suspect that there must be a record in the process table. Select star from orders processing queue. You see there was an error message and there was an exception occurred, right? So since this processing queue is not empty, this means that although we got an order from the user, but that was not able to get published from this order service, and it was also not stored in the orders journal table. You see, we have like many of the tables to go into and see the records, do the debugging, tracing. So that too was almost which I wanted to show you. Okay, one more thing I wanted to tell you, that this same kind of system will exist in the delivery service as well. Instead of this request API, we'll have an event consuming, and we'll consume that event in a DB table, and the rest of the processing will also be the same. So this same structure will be in every service. Every service will have this, and even the API request in every service will look like this only. And this is how this system becomes a fault tolerant system. This was demo which I showed, and that's all from my side. Does anyone have any questions? I know I could have like showed. Yeah, sure, go ahead.
Yeah, I was saying no questions, but it was a great session. Thank you.
Oh, thanks, Prakar. Although I could have showed
really great session. Thank you.
I request everyone, like if anyone have any questions later on, you can reach out to me and we can have like a good discussion over event-driven systems.
Bhavya, I have one question. Can you explain polling once again? The table, which one?
Okay. I can quickly show you that. So what polling is doing is there's an actor. I think I don't know whether you know about Akka actors or not. This is just an like Akka actors is for an asynchronous processing. What this actor is just this is just a process which makes a DB call to this processing table every few seconds, or it's a scheduled one. So this is just a scheduled process. So what it will do, it will do a select star from processing table every 10 seconds. And as soon as it receives a record, it will start processing it. So this is how it will do a polling game every 10 seconds, every 30 seconds, every 60 seconds. So it's just a DB call. That's all. And it is scheduled. That is why we have called this polling. You can maybe even reach out to me later on because we are already over time. We can discuss about this more. Right?
Yes. So there might be an automated job which is running.
Yeah, that's an automatic. Yeah, that's an automatic which is scheduled, which keeps on running in the background.
Okay.
So that's all from my side, guys. I think then you're welcome. Let's wrap it up and okay, we can end it, I think, and then we can discuss later on.